Python if, elif, and else statements. In Python programming language, it provides us the following types of decision-making statements: if and else, if, elif, and else statements. The if statements can also be nested. Let's see this. Let's assume we have a variable called number is equal to 10. We can create a simple if statement that tells us if it is positive. So if we say if, this is how you write your if statement. If number, remember our conditional statement, is greater than 10, then you end it with a colon, then take note of the indentation, then we can say print what? We should print the number is positive. Let's see if this runs. Oh, sorry, that would not run. Number is not greater than 10. So let's say 5. So we have our number as 10, and you know 10 is greater than 5. So let's do this. And as you can see, the number is positive, or let's just say greater than 0. So if number is greater than 0, it's positive, right? The number is positive. Take note of something. After that, you can always have your other block of code. We can say this will always run, just to show you that after the if statement has been executed, the code jumps out and continues execution of the next line of code. So you see, the number is positive has been printed, and this will always run is also being printed. So I'll just delete that so that we can have a clear environment. Now we have talked about the if statements, but what if we want to show, assuming we have a number that is lesser than 0, but we can't show that yet? So how do we bring that into the picture? We use the else statement. So we say else, you can then print out that every other number is negative. The number is negative. So let's say -10 and run, and you can see it says that the number is negative. So this is the if and the else statement. The if and the else statement is for decision making. It helps you to make decisions when you are writing your program. Now we have a second one, or should I call it in between, called the elif. So elif is like the if statement, but it means else if. So else if something else can run, right? So let's say else if number is equal to 0. Then we can print that out to say print the number is 0. You can have as many elif or else if as you want. So let me make the number to be equal to 0. Clear the environment. And as you can see, the number is 0 because our condition here is true. Number is equal to 0. Okay? Also, we can create a nested if statement. So a nested if statement is an if statement that has another if statement inside of another if statement. So let's see if we can change this code to execute as a nested if statement. So if I make this greater than or equal to, then I can come in here, take out this print. Okay, then let's create the first one. So we can say if if number is greater than 0, okay, we can go back to execute that the number is positive. Then we can create an else. Else what? else if, we can use the elif. So elif, actually let's just copy this and drop it there. So you see what is happening now is we create the first condition that checks if the number is greater than or equal to 0. Then when it checks it, if it is true, it jumps into this code and check if number is greater than 0. If it is, it will print the number is positive. Else if, it will check if the number is equal to 0, and if it is equal to 0, it will print that the number is 0. Then else the number is negative. So let's try this block of code. Let's make this 5, and I would run this, and as you can see the number is positive. What if we make it 0? The number is 0. And what if we make it less than 0? The number is negative. Also, you can do this without these brackets. I just like to have the brackets there because it makes it easier to read. But you can take out the brackets too if you don't want them, and your code is still going to run properly. So we can run this again. The number is negative. If I make this 0 and I run this, number is 0. And if I make this greater than 0, 5, and I run this, the number is positive. So guys, this is it on Python if, elif, and else statements, and we've been able to also create a nested if statement. So I would see you in the next video. Python for loop. In Python, the for loop is used to run a block of code for a certain number of times. It is used to iterate over any sequences, such as list, tuple, string, etc. Let's see this. Let's create two variables. The first one I would call, let's just call this name. Name is equal to precious. Then second, let's create a fruits list, and let's just list some fruits, probably my favorite fruits: banana, oranges, tangerine, peach. Now, in Python, like we said, a for loop is used to iterate over sequences. And if you can see this flowchart, you would see that it shows you something. It says it enters the loop, it tests the condition. If the condition is true, then it executes the body of the loop, and if it false, the loop terminates. So this is how it looks like. So first, let's start with our string. We can iterate over a string by doing this. So we say for, then decide on the variable you want to call what you want to call the single value. So I will just say x in name. Then what do we want to do? We want to print all the values of x. And let's run this to see. And as you can see, my name, all the single characters have been printed out on a single line. So we have P, R, E, C, I, O, U, S. So that is what it does. It runs inside and prints out everything that you have inside of the loop. Okay? Okay. Let's try something else too. Let me just call this numbers. There's also what we call range. So range helps you to print out numbers. Instead of writing 1 to 5 or 1 to 9, you can use range. So if I want 1 to 9, I can use range 10. Okay? And we can do the same thing. So for x in numbers, so instead of name, we can use numbers. And if we print all this out, you can see we have from 0 to 9. You can see what range does. So with range, you can get numbers quickly. Instead of typing them out as a list, you just use the range to get them all out. Okay, now let's proceed to using the for loop over our list. To do this, we will change this from X to anything. We can say fruit. So for fruits in fruits, for fruit in fruits. So because we want to iterate over all the fruits that we have, so each one of them is a fruit. So for fruit, that is apple fruit or banana fruit in fruits, print what? It should print fruits. Or we can make it more descriptive. We can say, okay, let's do this first. Fruits, print fruit. And as you can see, we have apple, banana, oranges, tangerine, and peach printed out on the screen. I could do this. I could say Precious loves what? Fruit. Run this. You see, Precious loves apple, Precious loves banana, Precious loves oranges, Precious loves tangerine, Precious loves peach. Also, we can use an else statement to show that the loop is done. So we could say something like else, then print there are no more fruits. So if I run this, you can see after it gets to the last one, peach, it says there are no more fruits. So this is how to use your for loop inside of Python, or basically this is the operation of Python for loops. I will see you in the next video. Python while loop. The Python while loop is used to run a specific code until a certain condition is met. While loop is usually used when the number of iterations are known. Whereas in for loop, while loop is used when the number of iterations are unknown, as against the for loop that you use when you know the number of iterations you want to run. So let's go. To create a simple while loop, we have to set an initial value, because like we said, we know how many numbers we want to do, right? So let's say we want to go to 10. Then the first thing you do is you say while counter. So this is the condition. While counter is less than 10, what should it do? It should print I am number counter. Then you have to set a condition. So you say counter is equal to counter plus 1. So this ensures that when the first while loop runs, it checks if counter is at the addition. If you add 1 to counter, it runs back again to run the loop till this condition is met. So let's run this. We have a problem somewhere. Okay, so we just have to troubleshoot. So what we have here, counter is equal to 10, while counter is less than 10, which is always true, so it's not going to run. So let's start from 0. So while counter is initially 0, so because we are going to increment it here, so there is no need to put 10 here. We only set the condition here. So let's go. As you can see, I am number 0 to number 9. And when it got to 9, it became 10, but counter is not less than 10. 10 is not less than 10, so the condition stops. All right. So you could actually do a lot with this. So we could do something like initial and final. So initial value is let's say 0, then final is 10. So while initial is less than final, then you print out I am number initial, and instead of writing it like this, counter is equals to counter plus 1 or initial is equals to initial plus 1, we can do it in shorthand and say initial plus equal to 1. Let's run this, and it goes again, I am number 0 to I am number 9. We can also use the else statement with this. So else, we can say something like I am done counting. Save. Let's rerun this. Let's make this 5. And as you can see, I am 0 to I am number 4. Then it says I am done counting. So this is it on Python while loop. I'll see you in the next one. Python functions. A function is a block of organized, reusable code that is used to perform a single related action. Functions provide better modularity for your application and a high degree of code reusing. So let's create our first Python function. To create a function in Python, you have to use the keyword def, which is short for define, but you say def. Def followed by the name of the function. So let's call this function let's call it greet, followed by the brackets, then a colon. Then inside, when I say inside, when you drop down, you use your tab, you can now have your block of code. So this function is going to greet us with hello world. Save. If I run this, nothing happened because all we've done is just to declare this function. The next step is to call the function. So after you've defined a function, if you want to run it, then you have to call it. So how do you call a function? You call it by its name, greet. Remember, this function was created as greet. So to call it, you have to call it with greet. And let's run this now. And as you can see, it says hello world because we have successfully called this function by saying greet, print hello world, and greet. Now, this function is very basic. Well, what can you do to make it a bit functional, so to speak? We use parameters. So parameters are like variables. So they act like variables that you send into the function so that you can use them inside of the function. So if I say fname, or let me say name, if I pass this parameter name, it means that when I call this function, I also need to pass an argument that is going to be the value of this variable. So, because if I run this now, there will be an error. And why is that? Because our function currently collects a parameter, but I did not send in an argument. So if I send in argument, maybe I use my name, Precious, this should work. You see, our function works, okay? But then, how can we use this name that I've sent in here inside this function? It's simple, because right now, anything you send inside here is currently available. So, I will just use name. So, hello world, Precious. So, if I run this, what do we have? Hello world, Precious. If I change this to Kim or Kimberly, clear the output, and I run this, you can see hello world Kimberly. Also, it can accept more than one parameter. So name, country. That means I also have to pass the 2 here. So I have to pass the country for Kimberly to Nigeria. So if I say hello world Kimberly, then I could do something like saying you are from country. So let's run this. Hello world Kimberly, you are from Nigeria. Now, there is something we call default value. So what if every time you may not pass a value, but sometimes you may want to pass a value? Then you can assign a default value to your parameter. So I could assign a default value of Nigeria to this parameter. And if I save this and I change this from Nigeria to, let's say, Uganda, save, clear output. If I run this, you see, hello world Kimberly, you are from Uganda, because I passed Uganda here. But what if I did not pass Uganda? Save. What would happen? Let's run it. Hello world Kimberly, you are from Nigeria. So you see, the essence of using the default value is, in case you did not pass the argument, it will fall back to the default value in the function. Let's comment this out. Now, something else we need to know is that a function can return a value. But before we do a return value, I want to show you something, the pass statement. So let's assume we want to create a function that adds numbers. And since we are adding number, we can have num1 and num2. What if we are yet to run this code? Like, we are yet to decide what this code would do. If we run this function, imagine you have this in a program. You're going to have a problem because there is nothing inside of the function. But if you use the pass statement, then you can leave it like this and it's going to skip it. See, there is no longer any error. So you can use the pass statement to ignore a function. All right, that's what I wanted to show you. Now we want to talk about the return statement. In the next video, we'll talk more about parameters and arguments, but I just did a simple introduction. So now I have 2 parameters in add numbers, num1 and num2. So what do we want this to do? We want it to do the sum. So we'll create a new variable called sum. Then it should add num1 to num2. And after doing that, it should return sum. Like like I said, if we want to call this function, all we need to do is say add numbers, right? Then we pass the numbers to it, maybe 5 and 10. If we run this, you see there is no output. The reason for this is because we are returning the sum. If I comment out return and I run this function, you see it's still the same thing. So sum is this, add numbers, then print sum. Now, the reason why you return it is so that you can use the value at any time. You can use the value at any time, not just when the function runs. So because of this, we can actually assign this to a variable, or you can print it directly. So we can say print, clear output, and run 15. So you see, anytime the function runs, we can decide to do anything we want with the value when we use the return statement. So return statement makes the result of a function, it makes it available for you to use at any point in your program. So like I said, we can even assign it to a variable, and we can say results is equal to the function, and now we can print we can say the sum is results. Save. And as you can see, the sum is result, because we use the return statement to make the value available, and we can use it at any stage in time. So instead of using the function in the print statement, you can assign it to a variable like result, and you can use it anytime you want inside of your program. So this is it on Python function, and we've been able to talk about defining a function and calling the function. Also, we talked about assigning parameters and also passing arguments. We also talked about using the pass statement and also how to use the return statement. So, see you in the next video. Python function argument. The terms parameters and arguments can be used for the same thing, information that are passed into a function. So, in the previous video on Python function, we already touched on arguments, but for the sake of clarity, let's do something again. So, I'm going to create a function that does sum, okay? Or let's say add numbers. And we can pass parameters to it, num1 and num2, because we want to do the addition of those two numbers. Then we can create a variable called sum. Then we can add num1 to num2. Then we can return sum, so that we can do whatever we want with the value. Now, if we do this, let's say we create a new variable called results, and result is going to be us calling the add number function. Then we can pass our variables to it, so we can say 5 and 10. Then we can now print results. You can see we have the return as 15. So basically, this is your simple Python function that does the addition of two numbers and gives you a return. Now, we also touched on default value. So what if we make num1 default to 10? What would happen if we run this function again? We still have 15, but what if we did not pass in a value for num1, or for one of the, we didn't pass in an argument for one of them? What would happen? Let's see. If we run this, num1, num2, okay, we have a default value is equal to 10. Okay, we can also have a default value is equal to 20 for num2. So clear the output. Now when we run this, you can see our return is 30. If I make num1 5, I want you to see what is happening. We still have 30 because this first one, this argument is replacing this parameter. But then you could see that previously when I did this, I had an error. So this leads us to what we call keyword arguments. So instead of just doing it like this, if I don't have a value for num2, then I can use the name of num2 to assign the value here. So num2 is equal to 10. So let's run this, and we still have our error. So let's see where the problem is coming from. Okay, so let's have a default for num2. So let's say 50. We have 50 for num2, but we are sending in a variable for num2 called with value 10. So let's see which one comes out. Oh, not saved, so I have to save. I guess I didn't save previously. So save, we still have 15. So this is what you have when you use named keywords in your arguments. So when you send in the argument, it uses the name of the argument to find what to replace. To illustrate this properly, I'll comment all this out, then I will create a new function that display info. So I will say def, I will call this user, Then we have first name and last name, L name. Then I would want to print the user first name, so I would just say first name is F name, so I will duplicate this, and last name is L name. Now, if I come in here to call this function by saying user, if I do this, precious Ariel, that's my name, first name and last name. This works. Okay, let me clear it. So this works. First name is Precious, last name is Ariel. But we can actually change how they appear. So normally, if assuming we have this here, Ariel first, that will be my first name for this function, which is not supposed to be. So if I do this, you see, first name, oh, I didn't save this. So I'll clear output and redo it. So you see, first name is now Ariel. To solve this issue, we can use the keyword by just saying L name is equal to this, and F name is equal to this. Clear output, and as you can see, it's working correctly now because we are using the keyword name inside of the argument to assign the values respectively. The next thing we want to talk about is arbitrary arguments. So let's see how that works. So you use star or asterisk to work with arbitrary arguments. So this is used when you possibly know the numbers of arguments that you want to pass. So let's say we want to create a function called countries. To pass in the arguments, you use what we call star args. It could be any name, but just to make it easy, let's use args. So arg stands for arguments. Then we can say print countries. So print countries. Then we can use our args here. Now let's call this function. To use this function, we are going to send in our response or our arguments as a tuple. Remember, tuple cannot be mutated, they cannot be changed. So it's better to use a tuple because you can't change the value of a tuple. So let's go. So we call countries, and we pass in the countries that we want to pull out. So Kenya, Nigeria, Ghana. You can see we can pass in unlimited numbers of arguments as you want. USA. So I'll stop here, and if I run this, you can see countries, Kenya, Nigeria, Ghana, USA. It brings the result out as a tuple. You can see it. So even if I had a new country, England, I can add more, Russia, still the same, we still get them all. This is because we are using the arbitrary arguments that you can use when you want to send in maybe unlimited numbers of arguments and you don't want to assign them to variables one by one. So let's proceed. The next one we will talk about is the arbitrary keyword arguments. So this is used when you don't know the amount or number of keyword arguments that you want to pass in. So let's recreate our user function again. And Since we don't know how many user arguments that we want to send in, we'll use what we call keywords in Python. So use ** kwargs. So it means it stands for keyword arguments. That's also what it stands for. Then let's go. So let's print out what we want to display. So I can say my name is, I'm going to use formats to output this. My name is Precious Ireo. I am from Nigeria. And I love Python. Okay, so I'll use format for this. Then the first one should be fname, lname, country, and let me just call this code. Now to call this, we would say user. Remember, it's a keyword argument, so we proceed like this. So fname is Precious, lname is Ireo, country is Nigeria, and code is Python. So I can see there is issue with the formats I'm using, so I will switch it around now. So let's just access it with the name of the variables themselves. So I'll take out the format, since we're not going to use the format system anymore. Then let's redo this. So my name is, then that will be plus keyword arguments, and the first one is fname. Then I want a space there, so plus, then this one is last name. Good. So my name is, yes. Okay, let's proceed. Plus, I am from, another plus because we want to put our keywords there again for country. So I am from, good, and this goes, and plus, and I love to code, so keywords code. Yes, plus keywords plus. Okay, good. So let's run this now and see. And as you can see, my name is Precious Ireo. I am from Nigeria. There should be a space here. So let me rerun this. My name is Precious Ireo. I am from Nigeria and I love to code. So you use the keywords to access the variable, the keys. So I use keywords to access the name so that I can access the value. So keywords fname is going to be Precious. Keywords lname is going to be area. Keywords country is going to be Nigeria, and keywords code is going to be Python. So guys, this is it on Python function arguments, and it was refreshing to have this video with you. Python function recursions. Python also accepts function recursion, which means a defined function can call itself. Recursion is a common mathematical and programming concept. It means that a function calls itself. This has the benefit of meaning that you can loop through data to reach a result. A good application of recursion is going to be what we call factorial. But before we go into factorial, you have to know that there is a limit to the recursion you can do in Python. So let's just check it out. So if I create a function called recurse, and we make this function call itself, so we can say return recurse. If we print this function recurse, let's see what we get. Recurse. Hope I got the spelling right. Oh, recurse, not print. Let's clear again and let's check where the issue is coming from. Recurse. Okay, let me take out the return. So this is debugging in action. We are debugging live. So you can see, oh, it was actually working. So this is what I wanted to show you. Previous line repeated 996 more times. This is recursion working. So Python is saying recursion error, maximum recursion depth exceeded. So Python puts a limit on how deep you can do, or how deep you can go when you are doing recursion. Okay, so that was what I wanted to show you. So now let's do our example. Let's do a factorial that will show us recursion in action properly. So I can create the function def. I can say factorial. That's not the right spelling. I just want to leave it as that. Then let's pass the parameter as x. That will represent the number that we want to check its factorial. You know what? Let's spell correctly. Factorial. Now let's go in. If x is equal to 1, then it should return x. Okay, so this is the first check, because we can't do the factorial of 1. So if x is 1, it should just return it back to us. We forgot the colon. Good, return x. Then else, this is where we now do our own factorial. Else it should return x times factorial of x minus 1. So this is the recursive function in action. Okay, so if you check it, this same function factorial is what we are calling again inside here, but every time we call it, we are reducing x by 1. So you have 3 times. If you have 3, you have 3 times 2 times 1. If you have 5, you have 5 times 4 times 3 times 2 times 1. If you have 6, you have 6 times 5 times 4 times 3 times 2 times 1. Okay, that is recursion. So let's create our variable for num. So we say num is equal to 6. Then we can print the factorial of num is factorial. The factorial of num is, that should be in quotes, space, let me put a colon here, is factorial of num. So save this and let's run this. So you can see the factorial of 6 is 720. Let's check for something else. Let's do factorial of 3. The factorial of 3 is 6. We can also check for 9, factorial of 9. The factorial of 9 is the number on the screen, 362,880. So the idea of the recursion is because factorial has to multiply itself when it is reduced by 1. So that is where recursion comes in for us. The function has to keep calling itself every time there is a reduction. So this is it on Python function recursion. I'll see you in the next one.